Hi everyone, welcome back to my channel. In today's video, as I promised, I will try to show you or explain the linear regression step by step with real example. So this, if you understand this lesson, it means you understand the deep learning, I would say the deep learning principle. So because the linear regression is the component, let's say, of each layer. So as I said, I will. This is the example here. I will explain it from the beginning. Let me just sorry. And here is the real example as well. It's explained in very details. So you need just to go through this video. And if you don't understand, let's say, or you need time, try to pause the video and try to calculate yourself. So this indeed this video or preparation it took much time, so please if you like it try to like it and subscribe, and of course if you have any question just drop it in the comment below. I will try to reply on your question. So let me just see what is the real linear regression. The linear regression is a kind of, let's say, type of supervised learning, but the the idea is to predict the target, let's say the target, but as a continuous value. So before diving into this stuff, let me just let you know what is the linear regression. So this assume that you have 2 points, let's say x and y. This is we have learned this from the school. So you have here the value of x, and here you have the value of y. Now, if you would like to write a equation for this, it's like this here, beta x plus beta 0, right? Or it should be like this, for instance, 2x minus 1. So as you can see here, for example, this is the value of x, and the value of y is here. The value of x is here, the value of y, for instance, is here. Is here. And this example, for instance, this is the 0 axis. Just try to focus here. For example, if the x value is 2, the value of y is almost 2.5. Okay. Now there's the y. It's like dependent variable. It means it depends on the x variable, right? In the x-axis, and y and x is independent variable. It's called independent variable in linear regression because it's not dependent on any variables. For instance, you have x. I need to find y. So y it depends on x. Now, what is the slope and y-intercept? The slope, it's the if you move, for instance, in x direction, how much y-axis will be jumped or moved? It might be negative or positive. And as you can see here, for instance, if you have 4, the value of y is 8. If you have 2, the value of y is 4, for instance here. Now, as you can see from this, it's if you just ignore this minus 1, if you can see y it's equal to multiply y 2x. It means 1 unit in x, it's move the slope, I mean the movement, or let's say the jump in y, or the value in y is 2. It's 2 times. So that's why we see the slope is 2. Now what's the intercept? The intercept is the value of y when x is 0. So for instance, for this simple equation, if x is 0, then y is equal minus 1. So this is why this is intercept is minus 1 here. Okay, so this is only let's see overview of the linear equation. So now let's just go step by step into the linear regression. So let me start with one example. I mean the house example. This example, just move it here, and it has, let's see, the house size and also the price. So if the size house is the 1000 feet, or I don't know, square meter, but it's square meter, it's too much. Let's see it. and the price is 200,000 euro or dollars. And as you can see, the way, oh, sorry, yeah, this should be the price. Sorry, the price, but it's just because the next example is wait, as well as this one here. I will change it. Sorry for this price, just to make it everything is clear. Now, if I would like to draw this and to draw let's say a line for this data here, and for example next time when I have the size, I will try to predict what should be the price, right? And as you can see, this formula here, the price is equal b beta 0 plus beta 1 multiplied by size. Now I would like to find b0, beta 0 and beta 1 that will be fit exactly to this data. And next time when I have, as I said, a new sample, or let's say a new house, and I know the size of this house, I will try to predict the house, the price. So let me just, for instance, in the first iteration, you will try to initialize beta 0 and beta 1 with, let's say, random values, right? And after that, as you can see here, I have, for example, the prediction, the beta 0 and beta 1 is randomly initialized. We will explain this in more details, don't worry. And the idea, or let's say the goal, is to minimize the distance between this red line here and each of these points. And in the first iteration, I initialize this, and I see, I calculate the distance, for instance, from this red line to this, it's almost okay. From here to here, it's not that okay. And from this red line to this, it's far away. So I need to minimize these distances. So I will try to update this beta 0 and beta 1 with the new values. We will see it in the next session. I mean, the next few minutes, and assume that in the next iteration I have updated based on the cost, or let's say loss function. And here you see I try to minimize the distance between these points to the line. And also after the third iteration, I have this, for instance, is much closer to the point. It's try to fit, let's say, to draw a line, the best line, the best, let's say, linear regression, it should move through these points. And as you can see here, for instance, after some iterations, I see the size, I mean the beta 0 is 0 and beta 1 is 200. And now if assume that you have a new size, right? Let's see, it's 500. So it will be 500, for instance, here. No, sorry, 500 will be here. Now the price should be 2. So 2 multiply 500, and it should give you y. And if you see, for instance, 1,300, it must be here. And if we go, for instance, here, it should be multiplied by 2. Okay. Now this is, let's see, with one independent variable, which is size, and one dependent variable, which is y. But in case in real time or in real projects, we have many attributes. For instance, you have the size, the location, the this some many, let's say, factors that will affect the price. So we need somehow real linear regression. It's not only for two x and y. It might be thousands of hundreds of attributes or independent variables. So I just give you one short example here, because we have, I just make it more, let's say, simple. So I have here the data set with, let's see, two variables here. The person one, it's just as index, just so you need to ignore it. And here I have height and age, and the predicted or the optimal, let's see, weight is 120. This is for the first person here, and this is for the second one, the third one, and the fourth one. And why we can't see if I have only three variables here, for instance, two independent variables and one dependent variable, I need to, if I want to visualize it, I need 3D linear regression. And if I have 5, 4, 10, and 1,000, it would be much difficult to draw it. But this example will try to explain everything in more details, so you can apply this concept, the same concept, even if you have thousands of independent variables. So now we need to find the weight, right? And the weight is equal beta 0, beta 1 multiplied by height plus beta 2 multiplied by size. When I change it to, I mean, the age. When I change this to age, I don't know, it's converted to greater or equal. I have no idea why, but that's why I just move it, change it to year. Let's see. Now, as you see, beta 0, it's the intercept. We know already what is the intercept. And the beta 1 and beta 2 is the coefficient of height and age. Now, this is, for instance, as a graph. Let's see, because as I said in the beginning, this will be the introducing to the neural network. If you understand this concept, it's 100% guarantee that you will understand everything in neural network. So as you can see here, I try to convert it to a graph. So I have here the independent variables and height and age, and each one has a parameter. And I have the weight. The output should be the weight from from this. This is, let's see, the class label or the predictable. We need to predict. The class label is categorical, and this is the bias or called intercept. Now this is, for instance, in the training. This is the forward. Now let's just make it much easier. Instead of weight, we need to find, let's see, y hat, and this height, it should be, let's see, x1, and this one, it should be x2, just to make it less text. Now I would like to initialize, for instance, I will use this use this to predict the weight of each person. And in the beginning, I will try to assume beta 0, beta 1, and beta 2 are zeros. Now, if I see here 0 plus 0 multiply x1, with x1 is 65, plus 0 multiplied by 20, and this one will be, the result will be 0, right? And you can see the y, this is the weight, the y is 100, but the predicted value is 0. Now, this is wrong, right? So we need an optimal beta's values that will try to predict the exact or close to the weight. Now the next step is to define, let's say, a cost function. So for instance, here I have theta y hat is 0. Now I need to move to update this to get the real, let's say, the real values. So that's why we need to calculate cost function. The cost function, it will try, after calculating the cost function, we will update beta 1, beta 2, and beta 0. Only beta 1 and beta 2 and beta 0. So please keep in mind that the data, it will be fixed. So you don't need to update any data. For instance, this data here will be exactly the same in each iteration. We need only to change only these variables: beta 0, beta 1, and beta 2. X1 and X2 has to be the same, and we try to find y hat. So this is the, let's see, the formula of how, because as you can see in this graph here, I have the y hat, it depends on three variables, right? That's why I have here g, so for instance, beta 0, beta 1, and beta 2. And because, as I said, y hat, it depends on these variables. And this is the formula. Let's see how to calculate the cost function. It's 1 divided by 2 multiplied by m. M, it's number of samples in your case. For instance, I have in my case is 5. And this is a summation from 1 to 5. And y0 minus y hat. It means y0 is this one, for instance, minus 0, right? And this is the case how to calculate it. But as you can see here, this y hat, what is y hat? Y hat, if you see only here, just y hat, I just replace it. I mean, I need to replace it with this formula here. So that's why I need to add it here to update the weights of each parameter. And it's the same of this function, or let's say formula, but I just replace y hat with this one here. And you can see here, for instance, beta 1 multiplied by x1 I. It means the first element in the table. And I have here summation to go through all the examples. Now, as you can see here, m it's 5. Y, it's the actual value, or the actual value of the class label of the weight of the person, for instance, I person. And this one is the predicted weight of each, I mean, y hat, or let's see, this y hat, or this one here. Now, as you can see here, we need to find the gradient. This is using the gradient descent. And the gradient descent, let me just go here. Gradient descent. Let's just assume this is let me just explain it in a simple way. So assume this is you are in the mountain, and you would like to find the the down of this mountain. You would like to get up from here. Now you will try to step. I mean, walk through your legs and try to step down. And uh, sometimes you will find this is not the right, let's say, the right jump. I have to go back, or no, I have to go left, or I have to go right. So this is because you are familiar with. I mean, you can see with your eyes where's the shortest path, let's say. But as an algorithm, it's not having the short path. So the jump size, it's considered as a linear, as a learning rate. But before this, let me just go to that. So this is the formula of calculating the loss function. Now I need now to find the gradient of each variable. So as you can see here, this is the formula. It's the same here. I'll just move down. And I would like to find the derivative of this formula here with respect with beta 0. So I'll give here one example here. Let's just consider as f of x is equal x2. And the derivative of the first derivative of this, you will have to move this 2 to here, 2 for instance, and x will be 2 minus 1, so 2x. This is the derivative of x2, x squared. It's the same as here. You can try to ignore this. Let me just focus on this part here. Now we need to find the derivative of this formula here with respect to b0. But because we have 2 here, I will try to move this 2 to here, right? And this will be the same as x, for instance, and this minus 1, it will be the derivative of 1. And this will be the same in all the derivatives. So in the next derivative, I will, let's say I have this, and the derivative, then the next let me just copy oh, let me just copy this. Hopefully it will be clear for you. Yeah, I have to copy the whole. It's even, it's not that easy to modify the formula, but no, I will have to copy, and let's see, paste. It's not showing the formula. Anyway, and let's see, you will have this from here. I mean, after the first derivative, I mean, not the first, after the moving the 2 to here, you will have only yi minus beta 0. And now what is this formula here? What is the derivative with respect of beta 0? So this will be minus 1, and the constant will be 0. Any constant, it will be 0, and this will be 1. So that's why we have minus 1, and because we have here 2, it will be removed with this, and it will be 1 divided by m, and I have the minus here because we have the minus of the beta 0. And it's almost the same for the beta 1. You can see beta 0, it will be 0, and beta 1, I have only x1I, and beta 0, it will be 0. I mean, beta 2, it will be 0. The derivative of constant, it will be 0. And that's why I have here multiplied, because here I have minus, it will be multiplied by minus xi. And the second one, I mean the third one, is beta 2. Consider this as, this will be as constant 0 minus 0 plus, but because it will be here minus, I mean minus 0 minus x2. That's why we have multiplied by x2, right? I mean, if you haven't understand this, please write it down in the comment. I will try to update to find, let's see, a way how to explain it in a much easier way. Now, as I said in the beginning, we have now calculated the gradient of each variable. What is the gradient? So the gradient is considered as what is the participation of this, let's say, variable to solve the issue. Okay, and consider beta 0 and beta 1 and beta 2 as steps, as not as steps, but as a parameter to reduce the error. Okay, now after calculating the gradient, I will try to update the beta 0, beta 1, and beta 2, right? So beta 0, it will be the beta 0, the old one, the old value, it was 0 in the beginning, but we will see it, minus the derivative of the gradient with respect of 0. I mean this value, this formula here. We will try to find this, and it's my beta 0 minus alpha. Alpha is the learning rate. Let's see the jump, how the step size. Let's see. For instance, if you are in the mountain, let's see, just in the mountain, and you have, let's see, did a big jump, for instance, in this direction, a big jump, but you will find afterwards, no, this is a wrong direction. I have to go to the, let's say, for the left. Now, to avoid this error, we need to make small steps. So try to make for smaller steps. And if you let's say move in the wrong direction, it's easy for you to go back instead of the if you made a big jump. Now it's almost the same as beta. I mean, this is the update, and this is really, I mean, the same for the all parameters. Now let me just, since in the beginning we have said in the beginning zero, beta zero, and beta one, and beta's values are zero. So y it will be zero, right? Now we need to update the values with sorry the values with respect with to these equations. Now, as you can see, I need to find the gradient of beta 0. Just use this formula here. It will be y0 minus the original y minus the y hat. And in this example, y hat is 0, right? It will be uh, this with the formula here. It will be minus 1 divided by m, where m is 5 in our case, 5 examples. Now open the brackets, this as this one here. 100, this is y, 100 minus 0, plus 150 minus 0, plus 160 minus, and etc. And the gradient of this will be 100 minus 164. Yeah, 46. And this is for the beta 0, right? And for the beta 1, you will do the same. It's, you can see here, I mean y, it's 120 minus 0 multiplied by x1, which x1 is, if you go back, x1 is 65, and the x2 is 20. But here we need only x1. And if you can see here, 120 multiplied by x1, which is 65. Then 150, I mean, plus 150 multiplied by 70, which is x1 as well. So this is 70. And the next one will be multiplied by 72, 86, and etc. This is for the beta 1. Because beta 1 is, as you can see, beta 1 is related to x1. You can see here, beta 1 is related to x1. So I will just use x1 here. And beta 2 is related, oh, sorry, to x2. Hopefully it is also here. Oh, okay. Sorry for this mistake. It's really a big mistake. But here in all equations, it's the same. I mean, it's right. Okay. Now let's go to beta 2. As you can see here, it will be 100, I mean, y 120, for instance, for the first example, 120 minus 0 multiplied by x2, which x2 in the first example in x2 will be 20. As I said, because beta 2 is related to x2, so I will ignore this x1. I will just use x2. And this, now I will find the gradient, right? Now I would like to calculate the weight. So it will be the weight of beta 0. It will be, from the next example, from the next iteration will be beta 0, it was 0 in the beginning, minus the learning rate was 0.01, and multiply by this value we have seen here with the gradient. So this is, for instance, B0, and from the next iteration, from the next update, it will be B0, it will be 1.64, beta 1 will be 102, and etc. Now, from the next iteration, I will try to use the same as, I mean, the same formula. So you can see I have updated the formula here just to make sure that you uh, uh, just I mean my goal is to make you 100% understand everything I'm saying. No, as you can see now, the y hat, it will be beta 0, which will be this value, plus this value, and plus this value. it was only a beta 0, beta 1, beta 2, just replacing the values of this. Now, if you see, I will try to calculate y0, y hat 1. So in the first example, you can see it was almost 0, right? And here we have now big values, because this values here, it's not that, let's see, good enough. But this for each sample, it will calculate the y hat. And again, we will try to calculate the residual x minus y hat, y minus y hat, and start and do the same stuff related to this. And I was trying and hoping that you understand this. And as I said in the beginning, this is the very basic of the deep learning. If you understand this concept, I'm quite sure you will understand the stuff. And I have also the same example here for the Python in a Python code. And of course, I will attach this with the video description, of course. As you can see here, this is for example, the prediction of 0, 0. In the beginning was beta 0, 0, 0. And the residual was the prediction was 0, 0, 0, 0. And the residual, this is the for instance, 100 y and y minus y hat. This is called residual, or the difference between the target, or let's say the real target, minus the predicted. And now we have the gradient of each beta, and we have the beta as well here. It's updated. You might see somehow there's some differences between the values we have extracted here. But of course, you know, the Python code, it's let's see, it's not that it's accurate. Of course, it's the same example, but sometimes it's used some other decimals. For instance, here you see it's 39 and point 2. Here it's different. But after many iterations, it will try to find the most relevant, let's see, values. And let me just see if I have 50 iteration. No, this is 20. 50 iterations. And let me just see here. Clay, oops, Python. And let me just copy the path of this file. And right, so I have 50 iterations. And you can see, let me just show you this. This is almost interesting. So from the beginning, as you can see, the residual was 100 in the first iteration. In the second iteration was too much. And the third iteration is also too much. And as you can see, from each step to to another one, it will be less. And you can see the residual is minus 2. It was here one. What was the value here? It was 2 million or 22 million. I don't know. And with every step, you will try to find the relative. I mean the good example, the good value of beta 0, beta 1, beta 2. And if you see here, I have now the value, the where I haven't printed the alpha and no, here's the alpha and beta. So this is, let's say, the final beta parameters. And of course, it's almost, you have the residual, it's still there. But if you would like to solve it in the beginning, you see, I have only 5 examples, so that's why it gave me somehow random data. But in your case, if you would like to have of course, you will have a big data, right? That's why we need to make it. I will attach this code, and you can try it yourself and try to replace this with your data. Try to load it from file or from somewhere else. So try to find the beta and as you see, here I have two parameters, no, two values, and that's why I have only three values, three beta. If you have five, let's see, five variables, you will have six betas. If you have 10 variables, you will have 11 betas. So all of these will try to participate in finding the best fit to your data. Okay, and that's it for today. And if you like, if you like this video and it helps you, please subscribe and like. And of course, if you have any question, write it down below. I will answer it, of course. Thanks for watching and see you time.